Hi, I'm Thomas. I'm a JavaScript developer working for Comsisto. And today I want to tell you how functional programming helped me getting here on stage at the ReactiveConf. And along the way, we'll learn some web scraping with algebraic structures. In 7 minutes is really short to tell you everything about algebraic structures. So what I'll try to do is to give you a 1 minute, very brief and incomplete introduction. And then I'll show you some code which is a bit more advanced. And if you heard about algebraic structures today the first time, maybe you won't understand the demo fully, but it's totally fine. If you start to get interested in them, I'll provide some resources if you want to learn more about them. An algebraic structure consists of 3 parts: values, separations, and laws. You can think of values as just JavaScript objects like the array, and this value has to implement certain operations. One of them is map, which you might know. If we have an array of 97, 98, 99, we map over it from char code, we get ABC. And on a type level, we changed from an array of number to an array of string. And the basic law behind map is that we try to keep the type which was outside, so in this case an array, but we change the inside from number to string. Another possible value might be the promise, but the promise does not implement all the operations that we need. So what we're going to do is we wrap the promise in the future. And the future has the same job as a promise. It's just some unresolved values. But it implements all the operations that we need. And every time I say a future, just think of it as a promise. All the algebraic structures are implementing the same laws. And these are the 2 structures we're going to use. What we're going to do is we're going to scrape this page. This is the open call for the ReactiveConf lightning talks. And about a month ago, I wanted to know how many stars I need in order to make it here on stage. And down here are all the submissions. And if you click on one of the link, then you get redirected to the gist with the star count. And instead of clicking to all the links, I just wrote a little script which does the job for me. And I already prepared a little bit of code. I'm using a library called Ramda, which is very similar to Lodash. From Ramda, we're using 3 algebraic operations and 3 helper functions. I'll explain them along the way. And we're importing the future. Then 2 functions. One is called load page, which expects a URL and returns a future. The other one, scrape page, which expects a selector, some HTML, and returns a list of DOM elements based on a selector. If we run this code, we get a response. And this response contains a data field with the actual HTML we're interested in. So what we're going to do is we wrap load page in a pipe. And a pipe is just the same as you might know from the terminal. You pass in some functions, and then each function gets a result of the former computation. So at this point, I would get the future from load page, and I do a map because I want to reach into the future without changing it. And then I prop the data field, so I get the actual HTML. Now I can create another pipe and pass this HTML to my scrape page function, which needs the selector. So we shortly go back to the page, inspect the first link. We're looking for the CSS class of the anchor tag. Oh, that's it. And if you run this code, we got a list of all the DOM elements. And what we want to do is we want to reach into the list and get what's inside. So it's once more a map. And within the list, we're interested in the attributes field, which contains yet another object. So we create yet another type, and we prop for the href field. Now we got a list of all the links from the page. We can just we're not interested in the first 2 because they do not lead to any gist, so we just slice them off. Now we got a list of all the links, and we can take some time to clean up the code. I move everything up which was related to finding stars. And then I move it back in, and everything's still the same. And we can refactor some code now further, because for all these links, we want to load their page and to get their data prop. So first, we'll get find stars out of the way, then grab all the rest, move it up. We give it another name. We call it crawl page. And down here, we wrap find stars in another pipe, and you pipe from crawl page to find stars, which does not work because what we did was we removed find stars from within the map here. And in order to make things work again, we need to wrap it in another map. And by doing this, we're actually following a mathematical law, the distributive law, which is a mind-blowing fact, but we got no time to explain that. So we just continue by mapping over crawl page. And now we got a list of all the futures, which is something we could work with, but it would be even better if we got a future with the list of all the results. And what we can do is we can use the traverse function, which is almost a magical method, because it can just flip any types. So we just flip from our future into our future. And now we got the future with the list of the results. The only problem left is that the future, the traverse returns a future, and the load page returns a future up here. So I got the future nested in a future, and in order to unnest these structures, I'm going to chain them. Now I have the list of all the HTMLs from the gist. And I just paste in some code which does the scraping and does some formatting with the stars count. And one last snippet is almost last is the find talks function, which gets me the titles from the blog page. And now I can use, that's really the last function, which expects the find talks and the find stars and returns me a list with all the titles from the blog post and all the stars count sorted by the stars count. And this list helped me to find out how many stars I need in order to make it here on stage. And I can even prove that my script worked by showing you these results of the lightning talk. I made the last place just as planned. And that's all I have about algebraic structures. I hope you liked how algebraic structures look like and how the code looked like. And if you want to learn more, follow this link. There's some resources about them. Thank you.